Greetings, science fans. Sefgi here. When you think of the planets, Jupiter and Saturn probably come to mind first, the showstoppers of our solar system. But lurking in the cold, distant reaches is Uranus, the seventh planet from the Sun, and arguably the weirdest of them all. Uranus doesn't have the flashy storms or rings of its neighbors, but it's a scientific enigma. Tilted, frigid, and full of surprises. Only one spacecraft has ever visited, leaving us with more questions than answers. Today, we're diving into the top 9 reasons why Uranus is the ultimate planetary oddball. Grab your curiosity. Let's get strange. Uranus's most obvious oddity? It spins on its side. Its axis is tilted a wild 98 degrees. Imagine a planet rolling around the sun like a knocked-over top. This means each pole gets 21 years of sunlight, then 21 years of darkness seasons like nowhere else. Scientists think a massive collision in the early solar system knocked Uranus over, leaving it permanently askew. Computer models back up this dramatic impact theory. The result? A planet with extreme seasons and a totally unique way of distributing sunlight. During solstice, the poles get more energy than the equator, the opposite of Earth. This tilt shapes everything about Uranus, from its weather to its magnetic field. It's the first sign that Uranus doesn't play by the usual planetary rules. A world literally knocked sideways, rolling through space ever since. Here's a cosmic head-scratcher, a planetary puzzle that has baffled astronomers for decades. Uranus is significantly colder than Neptune, even though it's substantially closer to the Sun. It's a counterintuitive situation that challenges our basic understanding of planetary temperatures. Uranus's upper atmosphere plunges to a bone-chilling minus 224 degrees Celsius, making it the coldest known atmosphere in our entire solar system. A truly remarkable and somewhat perplexing distinction. Why is this? Unlike other gas giants in our celestial neighborhood, Uranus barely emits any significant internal heat. It's as if the planet's internal furnace has been extinguished. Neptune, in stark contrast, radiates more than twice the amount of energy it receives from the Sun, acting like a miniature star in its own right. But Uranus is almost thermally dead, a frigid wasteland in the outer solar system. The leading theory to explain this bizarre phenomenon is that an ancient cataclysmic collision not only tilted Uranus onto its side, giving it its unique rotational axis, but also allowed much of its primordial internal heat to escape into space, or perhaps trapped it deep within the planet's core, preventing it from reaching the surface. With little internal warmth to drive atmospheric activity, Uranus's atmosphere is surprisingly calm and serene, lacking the wild raging storms that characterize Neptune's dynamic atmosphere. Its consistently frigid temperature is a direct and compelling clue to the planet's violent and tumultuous past, and its peculiar, still largely mysterious interior structure. It's a planet that consistently defies our expectations and challenges our preconceived notions about planetary behavior, even in the seemingly simple matter of how it manages to keep its cool, or rather, not keep its cool at all. The extreme coldness of Uranus serves as a window into its deeply buried and enigmatic history, a history etched in ice and whispered on the solar winds. It's a world seemingly frozen not just by its distance from the Sun, but perhaps also by a twist of cosmic fate, a destiny shaped by ancient collisions and lost heat. And that inherent mystery, that defiance of expectations, makes it all the more fascinating and intriguing to us as we continue to explore the vast expanse of space. If you think Uranus's extreme tilt is weird and defies expectations, just wait, because the surprises don't stop there. Wait until you hear about its magnetic field. It's not just unusual, it's downright bizarre. Unlike Earth's tidy centered field, which aligns neatly with our planet's rotation, Uranus's is tilted a whopping 59 degrees from its spin axis. That's more than halfway to being perpendicular, and to add to the strangeness, it is offset by a third of the planet's radius from the center. It's as if the magnetic field is trying to escape. Imagine a bar magnet, the kind you might use in a science experiment, shoved way off center, not sitting where it should be, completely out of whack. And now imagine that magnet spinning at a crazy angle, wobbling and whirling around. As Uranus rotates on its side, its magnetic field corkscrews wildly through space, twisting and turning in a bizarre cosmic dance. This creates wild, unpredictable auroras. Unlike anything we see on Earth, these auroras can appear almost anywhere on the planet, not just at the poles, painting the atmosphere with strange and shifting lights. Scientists think this magnetic field is generated not deep within the planet's core, as with Earth, but in a shallower, slushy ocean layer, a sort of electrically conductive soup. This ocean is primarily composed of water mixed with ammonia and methane, creating a unique chemical cocktail. This is much closer to the surface than anyone expected. This off-center tilted field is unique among the planets in our solar system, setting Uranus apart. This makes Uranus a natural laboratory for studying unusual magnetic phenomena, offering insights into how magnetic fields can behave in extreme conditions. Interestingly, its sibling Neptune also has a similarly strange field, suggesting a common origin or mechanism. This hints at a whole new way that planets can generate magnetism, challenging our existing models and theories. The result? A magnetic environment as unpredictable and chaotic as the planet itself, full of surprises and unanswered questions. Uranus's magnetic field is a swirling, lopsided mystery, a cosmic puzzle that continues to intrigue scientists. It's yet another sign that this planet rewrites the rules of planetary science, defying our expectations at every turn. And it's a puzzle that scientists are still working to solve, hoping to unlock the secrets of this strange and wonderful world. On Uranus, even the invisible is bizarre, a testament to the planet's unique and enigmatic nature. When we gaze upon the majestic forms of Jupiter and Saturn, we often think of them as the quintessential gas giants, massive spheres of swirling hydrogen and helium. They represent the archetype of a giant planet in our solar system. But Uranus is fundamentally different. It's an ice giant, a crucial distinction that sets it apart from its larger, more famous cousins. This difference in composition and formation has profound implications for understanding planetary science. Unlike Jupiter and Saturn, only about 15% of Uranus's mass is comprised of hydrogen and helium. This relatively small proportion of light gases is a key characteristic of ice giants. The vast majority of the rest is heavier ices, not the kind you find in your freezer, but compounds like water existing in exotic high-pressure states. And of course, methane, which contributes to Uranus's distinctive blue hue. We also find ammonia, another icy compound playing a significant role in the planet's overall composition and atmospheric processes. Deep inside, under immense pressure, these ices don't exist as solid blocks. Instead, they form a hot, dense, slushy ocean, a vast and dynamic layer surrounding a relatively small rocky core at the planet's center. This supercritical fluid exists in a strange state of matter. It isn't quite solid, liquid, or gas, defying our everyday experiences. It's something in between, exhibiting properties of all three phases due to the extreme pressures and temperatures found within Uranus. The key to understanding this difference lies in the planet's formation. Uranus and Neptune formed farther from the Sun than Jupiter and Saturn. In this distant region of the early solar system, icy materials were far more abundant than gases. As a result, Uranus and Neptune never grew massive enough to gravitationally capture huge amounts of hydrogen and helium like their larger siblings. This predominantly icy composition explains several of Uranus's unique characteristics, including its surprisingly low internal heat. It also helps explain its highly unusual and tilted magnetic field, a feature that continues to puzzle planetary scientists. Therefore, simply calling Uranus a gas giant completely misses the point and obscures its true nature. It's a planet built from fundamentally different stuff, with a unique formation history. Its slushy, icy interior is the key to unlocking many of its oddities and understanding its place in the solar system. By understanding Uranus as an ice giant and appreciating its unique composition, we can unlock the secrets of how giant planets, in all their diverse forms, can form and evolve within a planetary system. It represents a whole different planetary recipe, expanding our understanding beyond the familiar gas giants. And this recipe isn't unique to our solar system. It's one that's proving to be remarkably common across the galaxy, as we discover more and more exoplanets. Ever wondered what Uranus smells like? Scientists say rotten eggs. That's thanks to hydrogen sulfide in its upper clouds, detected by telescopes on Earth. Unlike Jupiter and Saturn, whose clouds are mostly ammonia, Uranus's are rich in hydrogen sulfide ice. This stinky signature tells us Uranus formed in a colder region of the solar system, where sulfur could freeze into the planet's building blocks. It's a smelly clue to its origins. So beneath that serene blue, Uranus is hiding a pungent secret. Beautiful to look at, less so to sniff. Despite the smell, Uranus is visually stunning, a pale cyan-blue orb. Its color comes from methane in the atmosphere, which absorbs red light and scatters blue and green. The result? A soft pastel hue, lighter than Neptune's deep blue. Scientists think a thick, hazy layer of methane ice particles whitens Uranus's color, masking deeper blues. Neptune's more active atmosphere clears out this haze, letting its blue shine through. On Uranus, the calm, cold air keeps things muted. Its color is a direct result of its chemistry and weather, a tranquil appearance hiding a world of strangeness. Uranus looks calm, but its winds are anything but. By tracking faint clouds, astronomers have measured winds up to 900 kilometers per h, twice as fast as Earth's strongest hurricanes. Near the equator, winds blow against the planet's rotation. At mid-latitudes, they whip around at top speed. This is puzzling since Uranus has little sunlight and almost no internal heat to drive such activity. Some scientists think deep convection or ancient atmospheric patterns power these winds. Whatever the cause, Uranus's atmosphere is far more dynamic than it appears. It's a reminder that even the quietest-looking worlds can hide violent forces. The source of these winds remains a major mystery. Uranus keeps its secrets well, but its winds show there's more going on beneath the surface. Saturn's rings get all the fame, but Uranus has its own set. 13 dark, narrow rings and 27 moons. Its moons are named after Shakespeare and Pope characters: Titania, Oberon, Miranda, and more. The 5 largest moons are icy, rocky worlds, each with unique geology. Miranda, the oddest, looks like it was shattered and reassembled, with cliffs taller than anything on Earth. Uranus's rings are faint and charcoal dark, discovered only when they blocked starlight. Their narrowness suggests tiny shepherd moons keep them in line. Voyager 2 revealed this miniature battered system, a solar system in miniature. The moons and rings hint at a violent, dynamic past. From a distance, Uranus looks serene, but up close it's a world of chaos and history. Its satellites and rings are as strange as the planet itself. There's still so much left to discover. Almost everything we know about Uranus comes from a single visit, Voyager 2's 1986 flyby. In just a few hours, Voyager 2 transformed Uranus from a fuzzy dot into a real world, discovering new moon's rings and its bizarre magnetic field. But a flyby is just a snapshot. We saw only one season, one side of the story. That's why scientists are pushing for a dedicated Uranus orbiter and probe. Such a mission could map the planet, study its atmosphere through all its wild seasons, and dive into its clouds. With ice giants common across the galaxy, understanding Uranus is key to understanding planets everywhere. Voyager 2's discoveries were just the beginning. Uranus is begging for a return visit. The next mission could unlock its deepest secrets. Uranus spins on its side, freezes beyond reason, and breaks every planetary rule. Its oddities challenge our understanding of how planets form and evolve. Studying Uranus isn't just about one planet. It's about unlocking the secrets of worlds across the galaxy. The mysteries of Uranus remind us how much is left to explore, even in our own solar system. What would you want to see from a future mission? Let us know in the comments. Thanks for joining us on this journey to the solar system's strangest world. Keep looking up and never stop questioning.